Hello everybody. Welcome to another video. Today, we're just going to go over some more preliminary information, very important foundational knowledge before we actually start solving some differential equations, which we will do in the next video. However, right now, these three items on the menu are incredibly important. It's kind of like these three, I guess you could think of as a visual analysis to some of the differential equations that we'll find in the future. Very important. And I'll get right to them right now. So come with me. First, let's go over normal form. You will find equations like this. dy dt multiplied by p of t plus p of t, q of t, those in r of t are all going to be like 3t squared. 47. Constants multiply by anything in terms of t. Let's not worry about y, the variable y being multiplied by any of these. Let's just look at this scenario, this linear scenario for now, where it's just the coefficients of our derivative are just in terms of t and constants. So what we have to do is isolate our derivative and get rid of the coefficient. Quite simple, we just divide. Very easy. See, I'm just getting your feet wet, okay? It's so, I'm easing you into it, alright? The water's not that cold, guys. Just come in, alright? It's so, alright, let's rock. Alright, let's do some examples, because this is so simple. You already got it. Look at you, man. Alright, so these are very obviously not normal, and I totally already underlined the coefficients, what you have to get rid of. Okay, so I want you to pause, actually. I can't pause, that makes no sense. You pause. I want you to bring these three into normal form, give me the order of the equations, and also tell me if they're linear or not linear. Pause, and if you forget how to do that, look at the previous video that I posted. Alright, you should have done it, so it's quite simple. What do? Divide by t squared minus 16. Easy. What do? Divide by x minus 5. Easy. What do? We divide by the reciprocal of the fraction. Easy. These are in normal form. Boom! Normal form is basically industry standard. When you're looking at solving differential equations, or what we're about to do after the next slide is called the interval of existence, you need to put this thing into normal form. But on the topic of the interval of existence, which is like the main, it's kind of like the heat of this episode. It's kind of like, that's like not just knowledge, like it's something you're actually going to have to solve and figure out. It's your first problem. There is one more piece of information you must know before you go into your adventure. And that is, what is an initial value problem? You've seen this before in Calc 2 or Calc 1, probably both, I don't know. Look, what is this? You're given a differential equation, you have an initial value. In this case, y of 0 is equal to 4, arbitrary, it could be any, y of t equals any whatever. The t is arbitrary. It's not like this. This is just an arbitrary example, guys. It could be literally anything. But this is just to show you that you're given this piece of information which you could use to solve for the constants that appear after you integrate and solve some of these differential equations, which we'll get to in the next video. But they're also important for solving or figuring out the interval of validity. And let's get right into that. What is the interval of validity? It's often referred to as the interval of existence. These are the same things. And it can be found using initial value problems, or the initial value information, like we got on the last slide. This dude, boom, 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 boom. We need this guy to figure out the interval of existence. And it is basically going to be the existing values that the solution is inside of. It's going to be an interval, quite a literal interval. Think of it like a number line of discontinuities, and then you're going to have, like, example, since it's y of 0 is equal to 4, you're going to find what two discontinuities 0 is in between. There's three ways to do that. Chronological steps. Or it's one way to do it, but it's the only way to do it. But there are three chronological steps to it. Bring it to normal form. Find all discontinuities in the equation. I don't know why I wrote function. It should be the equation. and then find the discontinuities the solution lies between. I got a bunch of examples for you. Boom, boom. I'm going to do this first one. You're going to do the second one. No cheating. All right. What are we doing? Normal form. Boom. Divide by t squared minus 16. We got this guy isolated. Next up, what we're doing. Find discontinuities. Plus or minus 4. T cannot equal 0 or anything less than 0. Cosecant, that's 1 over sine. Okay, sine is 0 for 0 and any integer multiple of pi. So it cannot be 0, pi. It already can't be anything negative, so it can't be negative pi because of both of these. It also can't be 2 pi, it can't be 3 pi. So we can, boom, write that down. And then we look at our initial value here. It's given y of 5 is equal to negative 2. So for the specific initial value, we find you could also write out a number line, put all these discontinuities on it, boom, 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 to visualize it. And you'd say, oh, 5 lies between the two discontinuities, 4 and 2 pi. Boom. Because on the left side, the closest discontinuity, if you're looking at it like a number line, is 4. And on the right side, since it's any integer multiple of pi, it's 2 pi. Which is approximately like 6 point something. Okay, cool. Yes. Now I would like you to pause and do this one. Sweet. I assume you've done it. You're supposed to pause. I hope you did it. Anyways, I'm going to go check your answer. Let's rock, baby. Normal form. Divide by x minus 5. By the way, I gave you a really easy one, so I really hope you did. In retrospect, I should have done this one, and you should have done this one. I should have thought about that, actually. That would have been much better. It's too late, though. So consider yourself lucky. I'm going to throw you a curveball next time. Anyway, so divide by x minus 5 is in normal form. What are the discontinuities? T cannot equal anything less than or equal to 0 because of our natural log. It can also not equal 5. I wrote 0 twice here just because getting the less than or equal to, I have to like copy and paste it online. It'll take forever. So I just wrote this twice. It cannot equal 0 and it cannot be less than 0. Yeah, okay, it means the same thing. I just put it in this kind of jumbled form, okay? I'm not going to something to copy and paste a symbol. That's ridiculous. I actually copy and pasted this one, though. Whatever. Look, that's not relevant. Let's just continue. All right. Now we say you could put this on a number line. Discontinuity is 0 and everything less than 0, and then 5. 1 is between 0 and 5, our two discontinuities. Okay, well, that means our interval of existence is probably going to be 0 and 5. Well, no, it's not probably, it is. Pretty simple, pretty important. This is like really elementary. Next video, we're going to actually start solving these equations with some basic methods, and I'll be introducing the ways to solve each equation by like, okay, we have like a linear homogeneous equation. This is how you solve that. I'll go over what a homogeneous equation is in the next video, or a linear non-homogeneous, and that'll be the next one. And we'll just go on to these different types of equations until you have a toolbox of tools. Okay, and by the way, when you approach these, put it in normal form. You could really learn a lot about an equation in normal form. That is my advice to you. Everybody, ladies and gentlemen, that is it. I'll see you in the next one.